So we're going to be making some sort of, let me turn off the section analysis, some sort of a little tea light holder. So again, this one, when I turn on the section analysis, you can see more clearly and shift into color mode. It's hollowed out, it is connected by threads, and it has, in here, I put a little approximation of the little tea lights we're using. Again, I have calipers for everybody to measure these tea lights. They're roughly an inch by an inch by an inch, which doesn't really work because we're working in metric, but we'll get there. I think that it works out to be about 30 millimeters, but I can't remember right now. Anyway, we will address how to get the correct size threads. And no, you are not required to have a certain size thread itself. It's much more about that the threads between the two halves match. Plus, a wee bit of an offset so that they will actually work once it's printed. I use the shell tool to hollow out the top. You're welcome to use whatever work makes sense, but shell is going to be the best option. Wall thickness, I will make a note of that. I recommend about a 1 millimeter wall thickness. So when you use the shell tool, about 1 millimeter keeps it thin enough. You don't want to go down too low because remember, the filament extruder standard is 0.4 millimeters. So if you go down to like half a millimeter, 0.5, you might run into some trouble. I would keep it at most, or sorry, at least rather, don't go down below like 0.8 or something, 0.8 millimeter shell. You make it too thin, and it's not so much it's going to be too delicate, but more of that the extruder might have difficulty keeping up with the design. That's all. But this one is using the form workspace, and we'll get to that one later. What I want to focus on first is different ways we can use the Sweep and Loft tools. So I showed you some examples of this kind of weirdo little ice cream scoop thing. Or let me reactivate the whole project. I have these couple of options of a couple of sweep tools, which takes a form and goes back. And this one I use back and forth, or just keep going straight up and you end up with like this nice like screw top cone. Um, or you could even get it much more experimental and sweep stuff around and around. So this one more of a non-centered lamp, much more Art Deco style. So you take whatever inspirations you want, go from there. So first off, I want to explain. Yes, I've designed. Leave me alone. I want to go over and explain just what am I talking about. The pipe, or sorry, not pipe. The sweep and loft tools. They both rely on a path. They have to have a path. So I'm going to start this up. Let me save. 0. Sweep and loft demos. So a path is simply a line, literally just a line. So I'm going to start with a sketch. I recommend y'all follow along just so you get the experience of playing with this stuff. So I'm just going to start a line on the XZ plane. So that's right in front of me, looking straight up. And I'm just going to literally draw one single line up like 100 millimeters, 90 degrees. That's it. Finished sketch. I just want a line. And that's going to become my path. Works for both the sweep and loft. Now, the difference here is sweep and loft both use a profile to sweep along that. You see what I'm saying? So there is one other tool called the pipe tool, and that generates its own profile along a path. Not really relevant for what we're doing, but just for the sake of conversation, a pipe tool, as you can see, takes that path that I just drew, and you can create shapes around that. This is based absolutely on that path. I can change from circular to square to triangle to even hollow. And all that is based on a path. My path could be that, or let me go back and let me draw just for the, again, for the sake of demo, a squiggly line. Let me hide that test pipe. And I'll start another one. Same tool on that. not a triangle. Let's switch back to circle. It doesn't like it if it gets too big. There we are. It will automatically generate. Oops, I accidentally made both of those. Don't want it on that path there. There we go. It will automatically generate a shape around that. And what it's basing that off of is a profile. In this case, the pipe tool. You can pick a circle, square, triangle. Throw in an X, you got a controller. But we don't want any of those. Yes. Sorry?
This is the pipe, not the spline?
Correct. I'm just showing you all that there is an additional tool that works off of this. So, and I should have split that off of there. So let me just take that away. I'm just going to delete this. You don't have to follow that part, but it's more of I just wanted to show you this. So the part I want to show y'all is the other tools. Sweep and Loft. Pipe generates its own profile. Sweep and Loft, you have to make your own. Sweep works off of one profile, and Loft works off of two or more profiles. So what is a profile? That's just a sketch that's perpendicular to that. So in this case, I'm going to start a sketch looking straight down. I'm on the the XY plane. And in this case, I don't know, we'll use a square or a rectangle. Actually, better yet, we'll do rectangle. Sure, whatever. There we go. So that can be my path. That can be my profile. I go to the sweep tool, and if it's not already up there, go to create and sweep. And what it does is it takes a profile and takes it along that path. So I select the path that I drew, the profile, and then the path. Now in this case, it's just going to create a rectangle because that's all it was. But you have some stuff you can play with. In that, I don't have to go all the way the entire length. I can actually twist and taper this as well. Like a taper, I don't know, we'll say 25. Tapers outward. Negative, it tapers inward until I don't even get a correct answer out of that. So let's go like -5 and get a trapezoid. Now that's tapering in all angles as it goes up. Just lose power.
Well, my computer has this weird thing every once in a while when it's touch screen looks out.
Right. Yeah. The other thing you could do is the next option down is twist. Now, it depends on how far you take this, but you can, in fact, do the twist. So 90 degrees, 180, 360. You can keep going as far as you want or as far as it'll let you. And this is what I mean by you can create some very intricate designs with very simple augmentations to these tools. All that is essentially a rectangle that I started playing with. Now I've got a pretty weird looking, or interesting, depending on how you look at things, shape. I could totally turn that into my lantern, but I don't want to. So that one is just a simple rectangle sweep. Let's get a little more weird with this. Let me start another sketch down here. I'm going to use the polygon tool. So if I go down to polygon, in this case, it doesn't matter circumscribed or inscribed. All that means is it creates the polygon inside of a circle or outside of a circle. Still bases the circle off of it still bases the design off a circle. So in this case, if we want to make our design, roughly, I said it needs to be like probably no more than say 60 millimeters. Type in 60. Do not click anything yet. My hands are off. Press tab. This allows you to cycle through how many sides do you want? 6, 12, 7, just to be awkward and odd, whatever. Go too many, like, I don't know, 28, and it's basically a circle. So that's going to be up to you. Keep the polygon count low, or keep the sides lower, and you'll have more to play with. You can align this, but you might as well keep it aligned to one of the major axes. Now click, and now I have a polygon to play with. You don't have to keep it as a simple as a straight-on polygon. You can add to this too. Like if I want, I don't know, let's see, it's simple there. Let's make that a 15 millimeter circle. So I'm just going to throw that in there just to show you some variation. Hit OK. So now my path can become this polygon plus, or sorry, I keep doing reversing those. My profile can be this polygon plus, and that can become my path. So I'll go to sweep again. My profile is that polygon with the notch taken out, or you can add them, whatever. It's up to you. I'm going to take it out. My path will be that first line I drew. Got that notch. Let's twist it again. This time, let's see. All right, 360 you got there. You can see where that notch shows up. You keep adding notches or alternating the notches, you're getting it more. Taper, if you want to have it come in or go out, that's fine. 45 gets excessive. Say 15 maybe. Some of these you might have to play around with just because, all right, the taper is too much for also the twist. So let's say like a 90-degree twist. All right, it's not liking both. There we are. So see what's happening with the twist or with the taper? Because I have this notch out, it's doing weird things. Basically the offset tool. So if you start augmenting the sketch too much, you're going to start getting some weird results. So with that in mind, we can play around with it or just leave that there for now. You can still augment in, draw, or you can sketch on planes, things like that. But what I wanted to show you with this is more so polygon test. I want to show you a sweep. Oops, not a pipe. Sweep tool with the standard profile, standard polygon, that path, and I want to show you what you can do by starting and stopping. So length, I don't want to go the whole way. Let's pick a number somewhere. 0.25. So remember, that's not the actual length, that's a partition of the overall. Your path goes from 0 to 1. So halfway in the middle would be 0.5. Quarter, 0.25. So whatever your actual measurement is, whether or not this is 100 millimeters, 200, 93.5, whatever, 0.5 is going to be right in the middle of that. So that's how that path thing works. It's a partition. So with that, let's throw a twist on it. Let's say 15 degrees. Okay. Repeat. Remember, you can right click to repeat the last thing. I don't have to go all the way down. I'm just picking that the top profile, go up again. Mind you, this happens. All you have to do is set the first number to 0. Oops, sorry. I always do that. Second number to 0, and we'll do 25 again. This time the twist will go -15. You can see where we're going with this. Repeat this several times. It is tedious. Second distance 0. First one, 0.25. Thing is it's just creeping up. So if you want, you can, if you want to kind of speed this along, you can, of course, pick a bigger number. And I'm just keeping with the same 15 degrees. Oop, not negative. So just twisting this back and forth, and we'll let it go the rest of the way. Second distance to 0. Twist angle. Keep getting it backwards. 15. If I threw in the tapers, you can obviously get that out of it. Positive goes outward, negative goes inward. Go more, 25, whatever. You see where I'm going with this. You can twist that stuff back and forth, back and forth. This is where you can really start to get funky with this. Eventually, what we're going to end up doing is using the shell tool to hollow this out. Now, remember, you can actually shell the entire thing by, before you click anything, select the top, select the bottom, and I said, like 1 millimeter. There we go. that's going to give us pretty well a kind of neato, weird, jagged lampshade start. That's not how we're going to start this, but this is the kind of shape you can build with this. So the next one I want to show you is the Loft Tool. So let me just type this in. Polygon, twist, and back. Yes.
Hit, turn.
One moment.
Oh, yeah.
All right.
Yeah.
So next I want to show you the Loft Tool, which is similar but different. So we can continue to use exactly what you had before. We can use this sketch. You can use that path. That's fine. But what a loft does is it uses two or more. So as I go over to create and mouse over the swath, loft, oof. And as you see, what it does is it transitions between 1 to 2. So it's a great way to merge different shapes, or you can hopefully not confuse the heck out of your model. So if you want, you can use the thing you're already using, but what it requires is different sketches. And the best way to make those sketches staggered, floating on top of each other, is with different offset construction planes. So to start, if you haven't already, pause what you got going. I'm going to reactivate my origin just so those show up, and I'm going to create a couple of construction planes. So we can use the symbol that's right above. That's the offset plane. If you go to the drop down, it's the exact same one, offset plane. And we're going to select where we started, the XY plane, and I'm just going to drag upward to, like, I don't know, 25. Okay. And I'm going to repeat that a couple of times. So repeat, offset plane. You can either start from the last one and go up again, like 25, or you can start from the bottom and move up however much you want. And the goal here is I want to end at the end at 100. So let's just say create 3 sketch planes, or rather, we're going to create 3 offset planes. At wherever you want, the original, one has to end at the top, and then 2 in between somewhere. I chose 25 and 25, and then the top is 100. So looking at it straight on, obviously that's not centered, and that's okay. That tool, construction plane. Yep, or offset construction plane. Yep. So make a few of those. Let's say make 3 for a total of 4. So make 3 of them. 1 should be at the end of your path, however long that was, and then 2 more in between. Your choice of distance. You can either drag and drop it or type in a number. Does not matter. All right, so we have our construction planes, and then what we're going to do is make sketches on those planes. So I'm going to create a new sketch. And while it's not absolutely necessary to make sure you keep them in order, man, can you get lost on this real fast. So let's just progressively go up. So the first plane I just made, snap there. Now I am looking straight down through all 3 or 4 in this case, but I'm working on the one I selected. So I don't know, pick a different shape. We started with a polygon here. Let's go with circle. And I'm going to make it slightly bigger just because. Hit OK. And you're going to do the same or similar for the next 2. So I'm going to start a new sketch. On the next one up, now don't go too crazy. As in, I went from a polygon, what is so an octagon, an 8-sided polygon, to a circle. Now if I go with like a square, like the same size-ish, things can get weird, but at least this one has these points to share. We'll go over what that means in a minute. I can make that as big, I get smaller, whatever. Finish sketch. The last one, I'm going to turn into a small circle. So the top there, concentric circle. And mind you, I'm building everything straight on top of the origin point. So it's all going straight up. You don't have to build your final one straight up and down, but in this case, let's keep it to that just so it kind of keeps the errors to a minimum. And I don't know, I'm just going to put like 20 in, something smaller. Okay. And then finish sketch. So you can see I have this odd progression of my polygon, a circle, a square, and a circle. Different sizes, obviously. Once you get to that point, we're going to use Create and Loft. Select there, and you'll see a new toolbox come up. Now, this part, doesn't matter if you start at the top or the bottom, but it is imperative that you select things in progression. If you start at the top, go to the top, next one, final, or the other way around. Otherwise, you cannot select them out of order. And hit OK. And we're going to see we got some weird shapes happening. Now, that's also because I have a progression of differently shaped profiles. If you keep them somewhat similar, you're going to have a more consistent result. The one other thing is if things get real weird on you, I'm going to right click, go back into the tool, the loft. There's an option here where it says guide type. The default is called rails, and that's just the naturally occurring edges here. The other is center line. If I select that and I select my original path, things will kind of snug up, tighten up, because it's basing the curvature of everything rather than on the outside of shapes and the progression of the profiles. It's basing the curvature of the shapes on that center profile line. So if you have a straight line, it's going to straighten things up a little bit. If you have a curved line, it's going to kind of snug things more to that curved line. But play around with Loft and see what comes out of it. In this case, Hershey Kiss. Eventually, we'll end up hollowing this out too. So if you want to test it, shell, I'm going to select the top and bottom plane. And we'll do 1 millimeter again. And there we go. Now I got a sweet little yurt. Yurt. No, not how you spell it. All right, so this part, like I just said, meh. We're going to actually cut this apart and add threads. So to do that, first I'm going to go back and delete the shell tool. I didn't need that to be shelled. Said delete. I probably accidentally hit configure. There we are. Because I want this to be a solid body. If you did, that's okay. But what we're going to do in order to add threads and stuff, first we need to actually divide this. So this is also where the construction planes come in. So what I'm going to do, and you can do this wherever or now, it's up to you. I'm going to start another construction plane, starting at the bottom, and I'm going to go up and mount. In this case, I don't know, 15, sure, whatever. Now you can see that floating out in space. Why is this construction plane larger than the other ones? Because there's there's an object already there, and it's just sizing the plane based around that. This whole thing is solid right now. I'm going to use the split body tool to chop this in half. So before I do that, I'm just going to relabel this. So loft shape. Sure. Oh, apparently I can't say it that way. Why isn't it letting me rename this? Weird. All right. Anyhow. So I'm going to use this construction plane. So I'm going to go up to modify, and it's this symbol, split body, or modify, split body. The body I'm going to split, my weird yurt thing. Splitting tool is that construction plane I just made. It's going to make a big circle around, hit OK, bam. Now I have a top and bottom. And this is what I'm going to build stuff around. So what I found is first we need to make a representation or at least take dimensions of, forgot that opened the other way, of my little tea light. Now, I think I recall, I forgot to get the calipers out, but I think this is about 36 inches, or inches, that's enormous, about 36 millimeters tall, right? So in order to do this, and I'm going to show you again, this is what we're doing. We're creating threads for the base and bottom and all that fun, and we are going to then shell it out afterwards. So in order to do this, I would say it doesn't really matter, but it actually does. I prefer, because my goal here in this one was to make this hollow. What I actually did is I created a void space inside and actually cut upwards 36, so or 36 millimeters. We'll just say that's what this was. I can't remember. I don't have my calipers in front of me. So in order to do that, it would honestly it'd make plenty of sense to do this one way or the other. But what I'm going to do, I'm going to say loft. Oops. Bottom. Loft. Top. Okay. So I'm going to take the top off, and just as a representation, I'm going to create a cylinder on that plane in the middle. This is going to be 36 millimeters wide. And I'm going to go up like 5 millimeters. That should be good. And I'm going to join. Okay. I can use these to cut away. So I'm going to turn on a section analysis just so y'all can see what I'm doing. Again, that's over inspect, section analysis, and I just select one of the perpendicular planes so you can see inside. So right now, I have my top of the little protrusion and the bottom. Well, should I go ahead and add threads to that? Not yet. Actually, what works best, I have found, because I have to make certain that I have enough space for this. And if I start adding threads willy-nilly, it might get too big or too small. So what I've actually found is it works best to make the recess in the top and add threads to that. So what I'm going to do is I'm going to do a combined cut. So my target body is the top, and my tool body is the bottom. Make sure you check the tool keep tools, otherwise you're going to delete stuff. So now my little nub matches the top there. And let me hide that sketch so that's a little less confusing. So now with this recess in place, I'm going to add my threads to that. Yes.
How did you get the wood again?
You could also just use a cylinder and just go straight up, but the void was created by adding a cylinder to the top of the bottom and then using combined cut.
You say 36 millimeter or 33?
36 we'll go with. I can't remember the exact number and I don't have the measurements in front of me. So I've got this little recess. Now I'd add threads to this, but the whole point here is, yes, I want to add threads, but if I add threads first and then shell, it will try to shell around those threads. So I can always go back in time, time travel with this, and add and splice in between, but just for the sake of streamlining, I'm going to go ahead and shell this out. So I'm going to use the shell tool. I need to select the bottom and the top, and then we'll do like 1 millimeter. So how is that different from what I did before? It also includes the bottom here, and now I have this little recess in there. That's how. So I use shell after I have that little recess because I want to make sure that little divot is there. Now save, recess, and shell. Okay, so we got it hollowed out with the shell tool. We have the little recess. Now we're going to add threads. So we're going to go to create and thread. And you're going to select that inside ring, that inside face cylinder of the recess we created. And and it's going to automatically generate some threads. And what you want to do, now it'll save space, but what you want to do is actually check the checkbox that says modeled. And you can see right now, it just kind of looks like a ghost of threads. When you actually select that, it will actually fully show the threads. And what that will do is that will translate better, and you can actually see what the heck you're doing. Now it's going to automatically select, since we had a 36 millimeter hole, it's going to go 36 millimeter threads. But the trick is those threads are going inward. That's what we definitely want. And if you want, I recommend where it says designation, that's just the size of the threads. It's going to stay 36, but the number of threads might want to make it less. So or it's actually finer. It's more threads, but you can go to 3 or you can leave it at 4. It's all right either way. And hit OK. And I'm going to turn on my section analysis again so you can see. So now the difference here. Before threads, after threads. And the whole thing is if I had tried to put the shell after the threads, it would have tried to shell into the area with the threads as well. That would be a major problem. Yes.
It might just be because of how.
And now the last thing on this, or sort of kind of, is now that you have threads in the top, we can unhide the bottom. See how those intersect? And now we can use the top to cut the bottom. Now, why would I not just apply threads to the bottom too? We're trying to keep these things aligned. So if I use one to cut the other, they will stay matched. That's the trick. And this little gap is occurring because it's not matching completely proper, but we're going to offset it anyway, so it doesn't really matter all that much. So in order to get these threads to get onto the bottom, we simply use the combine tool again. This time the target body is the bottom. The tool is the top. We cut, keep tools, and select OK. Now it used the top threads to cut the bottom threads to match. And the whole point there is now, rather than them being auto-generated, like if you've ever tried to make something like that before, it'll automatically generate. It looks like they're the same, and it probably should match. This guarantees that the threads match in that orientation. So we'll pause there and come back to it in a minute. Alrighty, so the last step was to get those threads cut on to the top as well using the combined cut. So we've got the top, got the threads at the bottom, awesome possum. Two other things, and then we're going to fiddle with this a bit. One, we need to make sure this thing has clearance, the threads, and then we need to actually make a spot for our little lady friend. So let's do the clearance part first. So I'm looking at this in section analysis mode. So again, this definitely helps. I would recommend using this just to help. Inspect, section analysis, and then you just select one of the major axes, whichever you want. Since this is kind of in the round, it doesn't really matter if it's the XY, or sorry, the XZ or the YZ, same diff. But what we're trying to get to here is we need to make a wee bit of a gap. So like this one, we need a wee bit of a gap with these threads here. So what we're going to do, now this kind of get a little buggered, but it shouldn't be a problem. Where'd my threads go? There we are. We're going to use not the push-pull. Do not use push-pull. That sometimes gives the like some funky results. We're going to use modify and offset face. But which one do we put it to? Because we only need to do it once. Well, if you hide the bottom, you don't have much room on the top threads. So let's do it to the bottom set. So we have the bottom exposed. I'm going to turn off section analysis just so you can see what I'm doing. And what I'm going to do is I'm going to go to modify and offset, not replace, offset face. And what this does is it's like the offset line tool, only it does it for a three-dimensional object. And I'm going to go around and I'm going to select, I need the top, the face, and the underside. And if there's more, make sure you get that too. See, I've got basically the whole set of threads. And I'm going to offset it negative, so it goes inward, 0.15 millimeters. Hit OK. So now, when I turn on section analysis and unhide the top, you can see that I now have an even gap all around. I have found that 0.15 is the sweet spot. You can go a little bit further, or you can go a little bit less. A little less if you have a really well-tuned 3D printer, and you're good. A little more, I get misalignment issues because there's too much of a gap. So I found that 0.15 millimeters is kind of the sweet spot there. Now, you will still have to do a little cleanup on threads because you always have to, which is just like a little bit of sandpaper around like the inside edge there. And maybe you have to then like actually physically work it back and forth a little bit as you, after you print these. But that 0.15 millimeter seems to be the real sweet spot.
Just gonna say, just be careful how tight you twist it. It will snap in your hand.
I was exactly what I was thinking of too. Also, if you happen to end up making an unexpectedly pointy thing, pointy printed things are very sharp. And like was just said, don't wrench it down. Oh, I'll just force it to thread. No, you'll force it to break, or you'll force it to draw blood as a penance for trying to force it. So when you print these, you will still have to use like a little bit of sandpaper or something to just clean. Usually, the topmost sides, the forward-most facing sides, and as you thread them, you'll hit resistance, work it back and forth. Don't just try to crank it and force it. It will either break or completely snap, get wedged. Exactly. All right. So we've got the threads placed. Now the last thing is, let's make a little spot for a friend. So I went and got a caliper and measured it, and luckily it's less than we made. So perfect. These are actually about just about 30 millimeters wide in diameter. Perfect because we made this thing 36. So we should have plenty of a gap. So let's hide the top and we'll put threads on here, or we'll put a hole here. Now the trick here is, well, poopy, I added threads here. So if I'm going to try and cut a hole right in the middle, well, that middle is offset. So let's try and see what happens, or better yet, don't necessarily go by the circle. We have the origin right in the middle where we actually want to cut the circle. So what we're going to do is we're going to use just a cylinder. We could sketch and extrude, but let's just skip that. Or you could even use the hole tool, which probably would work just as well, but I just want to show you this. Using the cylinder tool, just more of the same one we were already using. I'm going to select that top face, but I want to select right over the origin point. And we're going to draw that out to 30 millimeters. Look how close that gets. So this is where might not have been a bad idea to make those threads a little bit bigger. That's fine. But in this case, we're making it to there. And then height-wise, well, let's drag it down. How tall? Well, as long as it fits somewhat. The entire thing is more like 25 millimeters tall. To the top of the little sleeve is about 15. So, somewhere between there, let's say 10. Negative 10 to be exact, because I want to cut downward. There we go. So now I'll have my little recess for my somewhat awkward looking everything. I just wanted to knock out a quick little reference for what the LED thing would look like. Okay, so that will just at least give us space. But remember, too tight is too tight. So again, if I'm measuring that right at 30, which technically this is actually 29.5, so the 0.5 millimeters should give us already a bit more space. But if you find that you need to, you can again use that offset face to select that inner face and go outward just a teeny bit, like 0.15. Oops, negative 0.15. Just be cautious because we're creeping up on the side of the threads. And there you go. So that's pretty much a quick rundown on this. Now, obviously, I made a kind of silly looking thing. It probably won't print very well. And that's definitely one of the things we want to consider is like a lot of the original designs, not that one, because that's a whole nother set of issues. But like this one, as long as you don't have too much of an overhang or too tight of an overhang, you can go to right to print. But like this one we just made, yeah, that's kind of janky. You can always, like we talked about before, using the sweep or loft tools, you have the benefit of this being a parametric model. I can go back in the captured history and make alterations, and it will recalculate, hopefully with no errors. So something like, what if I don't like how wide that one was? What sketch was this? That one? Okay, let's go back in and edit that sketch. And let's see, how big was this dimension? 140? I don't know, let's change that to 120. That shrinks it up, recalculate all the things. What did I not do? Save. Whoops. So let's save this time. That shrank it down pretty small. Get it saved. But I've got this like weird, like kind of chef hat pinch thing going. Well, that's from the rectangle. You could always go in on maybe the rectangle, and maybe instead of it being sharp rectangles, you could go in and add fillets. Remember, if you want all of them to match, don't hit anything and keep selecting around. And now I can either click and drag or change the number, and it will alter every single one of them at the same time. So instead of that being a sharp corner, I don't know, let's do like a 6mm fillet. Yeah, constraints change. Recalculate. All right, I got basically a similar thing, but I didn't really change it that much. But like I was saying, the whole point of this is I can keep going back and making alterations. Say maybe I want it to be a wider top. And it will recalculate. Now, if you make like obviously really severe changes, you're going to get some errors. You're going to get some issues. But if you're just changing the sizes a little bit here and there, or what if I never liked where like the height of those sketches were? That's also where you can go in and actually change the height of the sketches by altering the construction plane, its height as well. You can drag it up and down, type in numerically, recalculate everything. Because that sketch is locked to that construction plane, that gives you control of all these points. That's why we're doing it that way, not just click and move a sketch up, but one, you have a whole bunch of like, you automatically generate a whole bunch of move tools and blah, blah, blah. It just muddies everything up. One word of warning, if you're using the loft, I highly recommend labeling all of your sketches, especially once you start stacking sketches, and labeling them in order numerically. You can keep with sketch 1 through 3, 4 if they're actually in line, but keep them labeled numerically. It is very, very easy to get lost in using a loft tool. But that's the basic rundown. Obviously, we need to make some changes. This is kind of a lackluster lamp for sure. I mean, it'd be translucent, it'd be fine, but it's definitely lackluster. So play around with those tools. You'll still be able to add the threads and all that the same way, but play around with them, get some more involved things, and hopefully it's a little bit less, or it's a little more thrilling than the one I just modeled. But you get the idea. Main places where you get errors. One last thing, when I turn on the section analysis, when we're talking about printability, if I'm worried about the inside edge here, while I don't really want to add a fillet or anything to the inside of the lampshade because it'll cause like it'll get like a weird thickness area, I would definitely recommend adding a thickness chamfer or fillet to this corner right here. I'm going to hide the bottom. The last thing I want to do is just add a little fillet or chamfer, it doesn't matter, to this ridge here, because what that'll do is that will make that area stronger. The threads are stronger, like the actual thread, it's less close to the wall there, and the transition will be easier. So as a threaded object, as a threaded 3D printed object that locks together, that will make for a stronger and more secure print. Just a little chamfer or fillet, doesn't matter, taster's choice on that one. But add the chamfer or fillet to that little corner there, and it will add strength to your print. Beyond that, this shouldn't even need any supports because the whole thing just kind of moves upward. You can have something that goes in and out, all of that. As long as your print doesn't go too severely, it doesn't break roughly like that 45-degree angle, you should be okay. 45 degrees is usually the cutoff of where you can print and not need supports. Keep it on the safe side, more of like 30 to 40 degrees, and you'll be a-okay. But that's our weirdo simple lantern. We'll add more to it. We'll make a more complex one later.